Ladies and gentlemen, welcome to this discussion. We are discussing a motion of bodies in circular path. So a body of mass 0.5 kilograms is tied to a string that is whirled in a vertical circle, making 2 revolutions per second. So we are told that the mass of this body is 0.5 kilograms and the number of revolutions per second is 2. So N is equal to 2 revolutions per second. But if we wanted omega, the angular speed is going to be, we want it in radians per second. So what we do, we already know that 2 pi, okay, 2 pi radians are in 1 revolution. So we know that 1 revolution gives us 2 pi radians. What about if we have 2 revolutions? Then we shall have 4 pi radians. So meaning here, the omega, our omega is going to be 2 times 2 pi radians per second. So which gives us 4 pi radians per second. So if the radius r is 1.2 meters, then find the tensions in the string when the body is at the top of the circle and at the bottom of the circle. So the system is like this. You are seated here or standing here and whirling this body here. So when you whirl it, remember you are going to be having your tension. Of course, the tension is always going to be in the string. So this is going to be T. There is also going to be mg. And what is trying to pull this outside the circle is what we call mv squared out of r. Or m omega squared r. That is when it is at the top. So at that position, when I resolve the forces vertically, forces vertical, T plus mg is going to be mv squared out of r. So T is going to be mv squared out of r minus mg. That is 1. Maybe I can call it T1. Then when the object is here, we have, first of all, mv squared or m omega squared r. But remember, we also have, the tension. If this is T1, this is T2. And down here, we also have, mg. So meaning, if I resolve forces vertically, then I will have T2 equivalent to mg plus mv squared out of r. So this is equation 2. So meaning, from 1, T1, or the tension when it is at the top, is going to be, mass is already seen as 0.5. We multiply by omega squared, which is 4 pi, times r, which is 1.2. So we have 0.5 times 4 pi squared times 1.2. So this gives us 94 point, this is actually minus 0.5 times 9.81. So this is 94.748 minus 4.905. And this is equal to 89.84 newtons. So tension in the string when at the top is equal to T1 is equal to 89.84 newtons. So while at the bottom, tension T2 will be mg plus m omega squared r. This is 4.905 plus 94.748. So which is equal to 99.65 Newton. So that's how we can deal with such a problem. At the top, the tension is going to be smaller than the tension at the bottom. So the maximum in here acts at the top, at the bottom, and the minimum acts at the top. So ladies and gentlemen, we are told that in a circus show, a motorcyclist is moving in a spherical cage of radius 3 meters, and the motorcycle and the rider together have a mass of 750 kilograms. Find the least velocity with which the motorcyclist must pass the highest point on the cage without causing contact inside the cage. So if he is not to lose contact inside the cage, then that means at the highest point here, this is the circus. So this person is in here with his motorcycle. So they are moving along here. So at this highest point, if the motorcycle and the cyclist, if they are not to lose contact, then that means, remember, at this point, they are facing vertically, they are actually upside down. But if they are not to lose any contact, then the centrifugal force and the weight must equal at this point. So m omega squared r and mg must equal. If they don't, then there will be a problem. Now, let's begin. What is the centrifugal force? Centrifugal force will be m omega squared r, and this is the same as mv squared, okay? mv squared out of r. So mv squared out of r is equal to mg. We know this, we know m, we know g. So I can cancel out this m, I can even cancel out m, so that I have v, which is equal to square root of rg. Do we know the radius? Yes. So this will be square root of 3 times 9.81. So v is equal to 5.42 meters per second. So that is the velocity. The velocity required will equal to 5.42 meters per second.